And if you remember, we did something like this. Sorry, I'm switching to my camera. Okay, this is right. So let us just start our project. Let us start the containers and then we'll access it from the terminal. So you start the series with make or docker compose minus f docker compose diff dot y and l. Okay. Docker compose no such file directory. Okay, we're in the wrong direction. So no. Oh, sorry. There was no need for.
Talk about the dev.
Yes. There was no need for this dev. Bind. We have an error message here attaching to this error from daemon driver for external blah 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 blah. So what this is saying is that this particular port has been allocated already. So what we are going to do is to delete all the Docker containers that I have currently running. Then when I'm done with that, I will restart the containers. Yeah. So let's search for how to let's search for the command used to delete all Docker containers. You can see this, we have docker remove this. So let's copy this to our terminal and then run that command. All right. Now let's run the Docker compose stop again. See what happens. Okay, it has now started. Are you?
Yes, I'm with you.
Okay, so what I was doing is like I initially wanted to start these containers, all right, but unfortunately I already have a container running on my on my system, and that container is also a database container that is listening to port 5433, and this container too that we want to start is also listening at that particular port. That's why we had that error. So to resolve the error, we simply copied the command we used to like stop and delete all containers, and we executed the command. And after restarting this, it works. Right. So we had a question in the last class. Let's go back to let's go to our terminal and look at that. I've forgotten the students that asked that question.
I think it was Ihame, so I'm not sure.
Yes, I think so. I can't really recall. So we were accessing the database from this terminal, and we did something like this: docker exec minus it, the name of the container, then psql postgres, then post Yeah, and the student said that he tried to play around with some of these values. Let's switch back to our VS Code. He tried to um, play around with some of these values. And you see here, Postgres user, Postgres password, Postgres server, port, and Postgres DB. And he actually changed all of this, all right? And at the end of the day, he wasn't really sure of which is which when running this command on the terminal. So how this works is, just give me a minute. So okay. So how this works is, let's exit. So can you see this first Postgres?
I'm seeing your VS Code.
Okay, yes. Oh, sorry. Let me switch back to the thing. Yeah, so can you see this first Postgres? We have docker exec -it. This string of numbers that's D44 E8070F2 is the container ID, like the container you want to go into or copy the ID. Now, PSQL, we already know that this first Postgres is the name of the database actually. Can you hear me?
Okay.
The first Postgres is the name of the database. Now, this last Postgres represents the name of the user. So if for example, this was something like this. If, for example, this our user was something like test, and our DB was maybe Twitter DB, right? The command we would have used would have been Twitter DB and test. So I hope that is clarified now.
Yes, yes, sir.
Okay. So let us go back to our code and continue from where we stopped. I don't think that guy is in this class, so maybe whenever he comes around, you can pass the information across to him, or maybe on Slack you can message him on Slack or something. So there's that. Now we want to actually complete this registration. We want to complete the registration, and we'll also build endpoints for authentication as well. So the very first thing we need to do is define the pedantic schema. All right, define the data schema. That's the structure of the data we expect to receive from the front end. And when we get this data, we'll start the processing, the password hashing, and storage to DB. So that's it. But before I start with that, I would love to ask if there is any question on what we did so far. So far, we've instantiated the project. We have registered the routers. We have carried out the database migrations and everything. So please, do you have any question on that before we proceed?
I don't have any question for now.
Okay, perfect. So what we are going to do now is to define the database schema. No, not the database schema. Is to define the data schema we'll be getting. So to do that, I will create a new folder within this library. The purpose of this library is that I want all our utility code to go in there. So I'll create a new folder that will store our schema. So I'll call this folder schemas. Then within the schemas, I'll create a file that will store our registration schema. So I'll call this file register.file. Now, within this file, we are going to define the schema of the data we want to get to our database. Okay. Users. All right. So when the user registers, we want the user to submit a username. We want the user to submit an email address, and we need the user to submit a first name, last name, and password. Then the other value should be optional. So we are going to create a schema that should make that possible for us. And to do that, we have always been making use of Pydantic. So import base model from Pydantic. So from Pydantic, import base model. Then we are going to create a register class that will inherit from this model, that's from this base model, and we'll then define the data we expect to accept to our register endpoint. So let's call this user create, and of course user create inherits from base model. All right, I want the username to be compulsory. Right, so we are going to set username is equal to, let me import field. Username is equal to field, and I expect this username to be a string. Now, since this value is compulsory, we'll put 3 dots here, meaning that this value has to be supplied. And don't forget, our username field in our database has a maximum length of 50, meaning we cannot store a value more than 50 characters in the username field of the database. So that means we should also restrict the username coming in from the front end so that the value isn't more than 50 characters. We'll do that with max length, and the max length I want to use 40. That means if a user submits username that is more than 40 characters, it will return an error to the front end. If we were to allow that to pass through and then come to our database, we'll get an internal server error, which I don't want. Then we should also have an email. Email should be of type email string. Then we have, okay, let me define the field as well. I don't want it to pass, the max length today is 100, but I don't want it to pass 60. Then I would also like to collect the first name and the last name. But of course, the first name should be optional. Okay, the first name should be compulsory, but the last name should be optional. So I want it to have a max length of 60. Then I need the last name to be optional. Last name should be optional, and we are going to import optional from typings. So from typings, import optional. So to make this last name field optional, we are going to wrap the string with optional. Then whenever this last name is provided, all right, though it is optional, but whenever it is provided, I want some kind of validation to be carried out. Now, this validation, I want it to validate the max length, which shouldn't be more than 60 characters. Now, don't forget this three dots we have here. This three dots specifies that this field is compulsory, correct? But we want this field to be optional. So we are going to change that three dots to none. Right. Let me recall. This field class takes in the first argument, right? And this first argument is the initial value. What I mean by that is, if this field is not provided from the front end, what do you want the default value to be? Okay. Now, when we use this three dots here, it shows that there is no default value, all right? And this field is compulsory, should always be provided. So in the case of last name, whereby the field is optional, we then set the default value to none. So if this field is not provided, we want the default value to be set to none. And if it is provided, I want the max length to be validated to 60 characters. Now, the next thing I would love to collect is the phone. I need the user to supply a phone. So it should be the same thing. It should be the same thing. I want this phone field to be optional. But whenever it is provided, it shouldn't pass 15 characters. Okay, there of birth, month of birth, and year of birth as well. I want them all to be optional. Year of birth. Month of birth and year of birth. Oops. So now we're done with that. Before we proceed, do you have any question on this?
Yes, sir. Good morning.
Yeah, good morning.
Yes,
I have a question.
Okay, please.
Yes, in the user model in user 05, I discovered that most of we have null, all of them set to null equals to true.
Yeah.
Does that mean that all the fields does not mean that it's optional? Like all the fields are optional, but I didn't fully understand what the null equals to true is.
Okay. That's a perfect question. So let me explain that in SQL. SQL is SQL databases are like structured database. All right. Let's say when you create a table, for example, this user class we have will be translated to a table in SQL when this is compiled and executed by Eric. All right. So when that table is created, there are specific fields for it. All right, let's say we have a table and we have a column for this, we have a column for this, we have a column for this. All right, those columns are specified. And in SQL, you actually specify the data type. Like you specify, okay, this column, what kind of data do you want to store there? All right, do you want to store an int? Do you want to store a char? Or is it a bool that you want to store there? All these things have to be specified. The maximum length and all of that, it has to be specified. Now, it is also possible for you to specify, like when you create a record, when you like create a record to that particular table, just like an Excel table, all right, is this particular column compulsory? For example, if I'm creating a user, is it really compulsory for me to input all these details? All right, if it is not compulsory, you can say that null is true. That means that you can actually create that record without supplying that particular data. All right. Then if you don't set this null or you set null to false, it means that this data has to be provided by that is compulsory that the data has to be provided. Now, this would still work if I did not set this null is equal to true, but I like designing my databases in such a way that any value can be skipped. All right, then the actual validation is done with parenting, right? Because I don't want a situation in which maybe if let's say, okay, let's just say I want to create a user and maybe the user doesn't. Let's say if we want to create an account and the user is asked to supply all this information, it will be too hectic for the user, right? So there's some information that can be skipped and maybe inputted later on. So that is only possible if you set your database to okay, if you set that particular table to ignore those fields if they are not provided. So that is the purpose of this node is equal to true. You can choose not to use it if you want that field to be compulsory. But I always love to set all my fields to null level. I mean, if I don't submit that particular data when creating that record, the SQL shouldn't give me any error, right? Then the actual validation, I prefer using this pattern. So if, take for example, in this user create, I can then specify that I want this particular field required, meaning that the user cannot actually create an account without providing that field. But on the database level, I usually don't like providing those, incorporating those restrictions at that point.
Thank you, sir. It's clear. I understand better now.
Okay. Do we have any other questions?
I have a question, sir.
Okay, please go ahead.
Yeah, so I want a clarification between when should we make use of tortoise model? No, tortoise ORM as a model, and Pydantic also has a base model. So when should we use a tortoise ORM model or Pydantic model? That is one. And number two is, what is the difference between a normal model and a schema model? When you are setting a database schema, when should we use a database schema and when should we use a normal model, a model.py?
Okay. Let me explain that. Your first question was the difference between tortoise ORM and this base model, right?
Yeah. When should we make use of tortoise ORM model, the model.model, and the Pydantic base model?
Okay. It's okay. When you are building a server, like what we are building here, we have the database. All right, we have the database, which is an SQL database. Right. So tortoise ORM is ORM is a short form for object relational mapper. It's something like an abstraction layer that makes it easier for you to interact with your database without actually writing SQL code. Because normally, let's say if you're a backend developer, you need to know your backend language, take for example Python in this case, and then also know SQL so that you can interact with the database. Now, the tortoise ORM comes into remove that restriction so that you can just use Python to interact with the database as well, like we are doing here. This user class, this particular user class is like a Python class, all right, that is then interpreted to that is then mapped to the database. Now, your question is, what's the difference between the tortoise ORM model and the Pydantic model, right? Now, this model is in a minute. Let me bring out the base model. Please note that this base from the first model, which is the base.py, all right, and this base model inherited from tortoise ORM.model. That's inherited from tortoise.model, right? Now, this particular model is a model you use to model your actual database, right? You use to create that mapping between the database like between the SQL and your actual code that you're writing in Python. You use the tortoise ORM model when you are interacting directly with the database. Right? For example, we want to, in this case, we want to create tables in the database. So we are making use of the tortoise ORM model to actually create that table. Now, Pydantic is for like the data that is coming to your API and out of your API. Right? Take, for example, we have from Pydantic import base model, and this base model helps you define the kind of data you receive from the front end. It's not working with the database. It does not interact with the database at all. It doesn't have any business with the database. It just helps you define the kind of data you want to receive from the front end and the kind of data you want to give back to the front end. Take, for example, this user create. We want to define the kind of data that the user needs to create an account. And we are making use of this base model that we imported from Pydantic. All right. So with this, we can then specify that we need the user to supply a username, which should be a string, and it should be composed with a max length of 40. We need the user to supply an email. We need the user to supply a first name, and all of that. This does not interact with the database. Right? We use this to just basically define the kind of data the user can get in and then capture that data. So that's really the difference between this Pydantic model, and the tortoise ORM model.
Okay, I understand now.
Okay, yes, you had another question, please. Can you repeat that one?
Yeah, as in, when should we have a normal mix of a normal models.py, like a normal database and a database schema?
Sorry, I'm not sure I really get it. Please, can you go through it again?
Okay, I said
you want, yeah.
Like, you know, there was a time we designed a database schema.
Yes.
So I was like, when should we make use of a database schema? We have a normal, okay, for a tortoise model that is interacting directly with the database. So when should we make, when should we design a database schema? Why should we design database schema?
Okay, that's a good question. I think let me confirm the specific class. When we looked at introduction to SQL, we then looked at some how to basically interact with the database with pure SQL. That's how you can create a table, how you can modify the table, how you can like add data to the table and take data from the table, search and do all those things. Now, when you need to use this tortoise ORM model, like this tortoise ORM model makes it possible for you to, like I explained earlier, perform these operations with normal Python, without having to use the pure SQL we used in that particular class. Now, if you want to create a table, all right, with your code, with your normal code, Python code, you can use this tortoise ORM model. All right. Now we can also use this tortoise ORM model. For example, we have created a table called user. We can also use this particular model to maybe search that user table, get the data from that user table, maybe delete data from that user table. Basically, whatever you can do with pure SQL, all right, you can then use this tortoise ORM model to do it. And we are going to see that in subsequent classes and in this class as well. Like, have I answered your question or?
No, as in, okay, I think I understand now, but when you haven't nailed the point on the database schema, as in, I mentioned something like a database schema. When should we make use of that?
Like when we should make use of the database schema?
I think there was a time we designed a database schema, yeah? So I was like, what scenario should we think of using a database schema?
Okay, basically, when you have an application, all right, that will be storing data to the database, especially if it is an SQL database, you need to design, when we say schema, it's just a fancy word for structure. You need to design the structure of the data you want to store in the database. All right. That's when you need to create the database schema. Yes, that's when you need to create that structure, that database structure.
Okay. I understand now. So, but lastly, sir, so as when you mentioned something like the tortoise ORM, like it can interact directly with the database. Does that mean that when we are making use of the tortoise ORM, we don't need to use a database like SQL Alchemy? Like I think I learned about SQL Alchemy with Fast API.
Yeah. So SQL alchemy is it's another ORM. There's, I said we make mention of object related mappers. That's ORMs. Right? We have different kind of ORMs in Python. We have the Django ORM. That one is used within Django. Then we have SQL alchemy. I think that's the most popular. Then we also have this Tortoise ORM. So yes, I don't think you can, there's no need for one to use more than one in a project, all right?
Okay,
You
sir.
can
Okay,
use
sir.
SQL alchemy if you wish to, then you can use Tortoise ORM if you wish to. But I actually prefer Tortoise ORM because it makes this async operations like much very easy. You can easily await, you can like the async syntax is more mature in Tortoise ORM than SQL alchemy, actually. So that's why I prefer Tortoise to SQL. That's
Okay,
SQL alchemy, not SQL.
okay. Thanks, sir. I understand better now. Thank you, sir.
Okay. So please, do you have any other question apart from that?
Yeah, none from me.
Okay. All right. So now that we have defined the kind of data we want to get from the user using this pedantic base model. Right. Please don't confuse this base model with this other base model. All right. This base model we used to create the this database schema is not from Pydantic. It's not from Pydantic. Don't forget that the base model we are using to define the data that we are collecting from the front end, that's from the clients, is imported from Pydantic. But this one we are using here is a base model that we created here at twitter.models.base.py. We defined a base model that we can use that all our database models will inherit from. And with this base model, we define the ID so that each of our models we create should have an ID field, should have created that field and updated that field. All right. And this base model we created inherits from tortoise.model. All right, please don't confuse the two. I think maybe I should rename this, but I don't want to do that now. This particular model is very, very different from Pydantic.base model. All right, so to actually get this data, I want to import it from, we are going to import this from libraries, that's from library.schemas.register import. I want to import user crate. All right, now we then get to our register endpoint. All right, we then specify data. We want to collect the data that is of type user crate. Yeah. All right, so with this we can just first let's just pass. All right, let's not do anything. Now I'm going to run this project and we'll look at it at the browser. We'll look at the docs at the browser. Right, now let's go to our browser and check that out. Value error. We have an error. Value error on field email. The following field constraints are set but not enforced. Max length. Email field max length. Okay, let me remove this. That should be the source of the error. Okay. So I'm switching to my browser right now. Now let's look at the docs. All right, so this is the register endpoint that we just created. And can you see what we have here?
Yes, yes.
Yes, so these are
Yes.
the fields these are the fields that we defined with Pydantic. All right, the fields we defined with Pydantic, the fields we'll be getting. Let's try this out. So unfortunately, this does not specify the fields that are optional and the ones that are required. But these are basically the fields that we defined in Pydantic. So if we execute this, it will not do anything, of course, because we just passed everything. All right. So let's go back to our VS Code and do something from it. All right. Oops, one more thing.
We didn't return anything.
Yes, we didn't return anything, and we didn't collect the password. Don't forget that users are registering, so we need the password as well. So I don't want password to be optional. It should be compulsory. And it shouldn't have an initial value. Now I want the minimum length. I want the minimum length to be 8 characters and the max length should be 1,500 characters. So that's that for DB. That's good. Now the next thing we are going to do is password hashing. The next thing we are going to do is password hashing, and I think a couple of classes ago we actually looked at how to do that. So give me a minute. I just want to copy and paste the code, then we'll go through the code again so that we will not waste so much time. So we are going to import bcrypt. Oops. Yeah, we're going to import bcrypt. Did we install bcrypt to this service? Let's check. Parsley bcrypt. Yes, we did. So we're going to import bcrypt. Then we are going to import Parsley. That, and the next step would be to instantiate Parsley. The next step would be to instantiate Parsley. So we will do that here. We'll set the script context, that's password context is equal to create context using the bcrypt schema, and deprecated is equal to auto. Now the next thing we are going to do is we are going to use this password context to actually hash our password. So we'll do that here. So password hash is equal to bwd context.hash, and I want it to hash data.password. Good. So with this, we should have a hashed copy of that data.password, and that is what we'll be storing to our database and nothing else. Please, does anyone have any question on this? We looked at this extensively about should be 2 or 3 classes ago. So I'm just copying and pasting code so we can proceed. Is there any question on this?
It's clear for me. It's clear for me for now.
Okay.
It's clear, sir. We can remember.
Okay. So we are simply importing crates and then we are simply importing this. So there's no need for this to be crypt. Let me clean it off. So we are simply importing crypt context from parsley, and then we instantiate the crypt context using the crypt algorithm, and we use that the instance of that context to hash the password the user supplied, which is accessible at data.password. That's this particular password that the user entered. So now we have that password hashed. Now the next thing we are going to do is to just save this data to the database, right? To do that, we are going to import this user model. We're going to import this. So from models user import user. From model.user import user. Now we are going to actually create this account now. All right. So we're now going to call the create method of user, right? And this create method actually converts whatever data you pass to it, and stores. It creates a record in the database, passing in the data you are passing through. So in this case, I want to pass the data this user supplied, all right, the data the user supplies. So to get that, you can actually do something like this. First, I want to show you something. So you can do something like this. Username is equal to data.username. Email is equal to data.email. Yeah, I believe you understand this, right? That we are creating a user. There's a user instance, a user record with the username equal to data.username. That's this data is of type user create. All right. Now, if you come to user create, you see we have a username field and email field and all of that. So the username of our database will be equal to this data.username. That's the username that is passed into our API to our endpoint. All right. So using this method will be too cumbersome because you need to enter all of this. You need to enter all of this, which doesn't really make sense. So TotalsORM comes with a different way of saving data to the database. You know, you can actually use a dictionary. Right? You can pass in your data as a dictionary, and it will still be saved to the database. So thankfully, there's a way you can convert this pedantic model to a dictionary. There's a way you can convert this pedantic model to a dictionary. So you do that with data. You call in a dict method. You call in a dict method, generate a dictionary representation of the model. Optionally specifying which fields to include or exclude. So when you call that dict, you generate a dictionary representation of the model. Whatever data was passed into the model will then be converted to a dict. Now you can then set some things like exclude on set to true. What this means is that whatever value wasn't included will be excluded from this dictionary representation. Take, for example, the last name is optional, all right? So since the last name has not been set, the resulting dictionary will not have a last name key. That's what that means. Now we also want to exclude this password field, right? Even if this password is provided, I don't want it in the DB. So we can then type in exclude. Which field do we want to exclude? We want to exclude the password. Now, one more thing, we need to spread this data. I think we spoke about spreading the spread operator a couple of classes ago. Like it merges the dictionary into, it basically spreads the dictionary. This is what I mean. How do I do it? Okay. Let's do it like this. Let's see if we return detail. Hello. No. That's okay. So first, let us test this first, and see what happens. All right. Now let us use this. Okay, so I want to test that endpoint before we proceed. The other fields are optional except passwords, so let's enter that. Okay, so let us test this. All right, and let's see the response. Okay. So can you see what we have here? Now,
Yes.
yes, now there are situations in which we will need to take, for example, I don't want, like I want something like this. I want something like this. And you see this username, email, up to password, it is in a separate dictionary. It is in a separate data dictionary. Okay, what if I want all of this to be in a single dictionary with no nested dictionary in between? All right. In this dictionary, in the return to response, we have data is hello. Then we have another dictionary that is data, all right, and it also contains its own value. If I don't want this data dictionary to be here, and all this data is available in the initial dictionary, we can make use of this spread operator. This is what I mean. It will then spread this dictionary into the initial dictionary. So let us test this. Yes. So can you see what I mean?
Yeah. Nice.
Yeah. So if
I
we
never knew what those aesthetics here for.
Yeah.
So everything arranged in one dictionary, in one JSON response.
Yes, everything arranges in one in a single dictionary, without needing to like create another nested dictionary in between. Okay, so we need that here, right? We need that here. We actually want this dictionary to be spread into this user.crate. We want it to be a single dictionary. That is why we're using these two asterisks in front of the data.dict, right? So when you do this, it will then go ahead, spread that dictionary into the crate, and then actually populate the database with those records. Now, the next thing I want to do is I want to return that created user. I want to return that data to the front end. And before I do that, we should also specify another model, because can you see here, if you return it like this, it should return everything. Let me see if this will even work. Right, are you guys still there?
Yes, sir, we're here. We're here.
Okay. So let us test if this will work. Okay. All right. Hashed password. Okay. Can you see my screen?
Yes, you can see your screen.
Okay. So there's a bug. We actually did not save the hashed password. All right. That is why we're having more. Okay. So now let me save the hashed password as well. So now that we have defined the crate, you can specify any other field you want to create. And in this case, I want to create the hashed password as well. So I can specify that now. Let's check my model. It is called hashed password. So authenticated hashed password. Okay, let's run that again. Good. Can you see this?
Yes.
Yes.
Yeah. We have the hashed password returned to the client, which is a security issue. Right? It's a massive security issue. So when user creates an account, the user doesn't need to know the hashed password. All right. We don't need the user to like see this hashed password. This is something that has to be on our server. The front end doesn't need to know about it. So what we're going to do now, like to eliminate this error, to eliminate this bug, is to define another model that will be responsible for the data that is leaving our API. right? In the case of register, the data coming in was called user create, right? Now the data we want the user to see, like the front end to see, we could call it maybe user public, so that in that particular schema, we can exclude the data that we don't want to give back to the client. So we are going to do that. I'll create a separate class for user public. Now, of course, inherit from base model. Then I want to give back just everything except password. All right, I want to give back everything except password. So I can simply just copy this. There. Now we don't need the validation because it is data that is leaving our API. Of its integrity, so no need to. Okay.
The first, sorry, sir. The first string is
No.
First string is string. Username. The string is capital S is capital. Does it matter?
Oh, please, thank you. Thank you. It does, please, it does. Thank you. We are going to remove that. All right. So we are going to import that to our endpoint. User public. Now, can you see this register.post? It also accepts another parameter. It accepts another parameter, response model, which specifies the model of data, the structure of data you want the response to be, right? And in this case, I need the response to be of type user public. It should be of type user public. So with this, please don't forget, if you look at the user public, you see that it has every single data with the exception of password. All right. Now, I also need some other data to be provided as well. I think I need the ID. We need the user ID, which should be of type UUID. Okay. Let's go to our models. Okay, our ID is of the UUID field. So this will be UUID. From UUID import UUID. So I want my ID to be UUID. Now we should also get the. Don't forget that each model has a created and updated field. So I want to return these values as well. So you can bring it down here. Created at, I'll come back to the data later. And don't forget that these fields are datetime fields. All right, that means the data type will be of type datetime. That means we are going to import datetime from datetime. Datetime import datetime. So we'll use that datetime as the type. All right, so we are done with that. Is any question on this? Any question on this? So user public is the schema that we want to give back to the client, right? That's what we want to give back to the client. And user create is the kind of data we want to get from that client. And of course, we don't need the ID because this ID is created automatically. We didn't need the created data and updated data because these fields are created automatically as well. But we need some other data to return. Yeah, I think I've forgotten something. Email verified here is very important. We also need email verified to be in the user public response. And email verified is of type bool. So we'll specify that as well. Now let us test this again. Okay. Let's test this again and look at the response. All right, so now can you see my response? We have the ID, we have the username, the email, first name, last name, phone, date of birth, blah, 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 then created that. All right, which is the exact time in GMT, that's in GMT plus 0, that this record was created, and email verified, which specifies if this particular account has been verified. And it also supposed to return updated at, but at the moment, the field is null. Why is it null? Because we have not updated our data yet. As such, the field is null. So with this, we are done with the account creation. Is there any question on this? Any questions so far, please?
None from me, sir.
Is any question? Okay. All right. So we all understand the password hashing. Why we need to use a separate schema for the data in and data out of the endpoint. Okay. Okay, now the next thing we are going to do is we are going to create an endpoint for email verification. All right, we need to create an endpoint for email verification. So how this works normally is that, you know, when this account has been created, sometimes you observe that maybe when you sign up on a platform and when you sign up on a platform, you get an email like that you need to verify your account, blah, 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 blah. So how that works is that when you, after line 16 to 19, you know, then it's from line 16 to 19 that we actually create the account. Now at line 20, we can construct an email. I will not do that here, but I will put a comment, construct email that sends verification token. We can use maybe random to run it, import random. Now, random is a library in Python that you can use to generate random numbers or anything random. So random dot rand int, instantiate that. Maybe return random integer in range A to B, including both endpoints. Okay. Let us use random dot rand range. What does that do? Start, stop, choose a random item from this fixes the problem with runtime, which includes the endpoint. Okay. Start, stop, step. Okay, you should start from 4, you should stop at 90 with a step of 4. Okay. Maybe with a step of 10. Now this would create a random number. And let us print pending verification token, and this should be an F string. I want to pass in the token there. Now let's see what happens. All right. So if you look at my terminal, you will see the sending verification token 39. So this is how it works. Like after the registration, you can then create a token. You can then generate a token and then maybe store this token somewhere and send it to the client, or maybe send it as an email to the user. Now this user will then supply this token. And from there, you use this token and maybe effect the account verification. Right. A good example of that would be maybe we can create a model for. We can create a model that stores these tokens. Then, or maybe you can store it on Redis. All right, we can store it on the Redis. Then we then send this token to the front end, or we can send this token as an email to the user. Now, we will then create another endpoint that will handle email verification. Now, when a user submits this token, we will then take this token and then check our Redis database. If this token exists, we extract the user that owns this token and verify the user. And if this token does not exist, we reject the request. All right, so do we have any question on that? It's like that will be your next assignment actually. So do you have any question on that?
Okay. I have a little question. The generation of the, let's assume the token is generated like it did now.
Yeah.
Are these tokens going to be unique? Because what if the random one is generated and still maybe it comes out, since it's randomly generated and it comes out to be the same with someone else?
The network is bad. I don't know if it's my network or your network. I'm struggling to hear you.
Yeah, I think it's my network.
Okay.
I think it's my network. Can you hear me clearly now?
So can you? Yes, I can hear you.
Okay, so I was saying, since this token is generated randomly, like in this case now we got 39. What if a random one was generated again and it coincides with someone else's token? Is there a case? Is there how we can make the tokens unique so that tokens are unique per user?
Yes, definitely. You've asked a very perfect question. So let us do like this. I'll create a class. I'll create a class that does exactly that. Then I'll show you how that can be done. So let me create a security folder in libraries. Oops. Let's create a new folder and I'll call it security. And within this folder, I'll create another one OTP, right? Now within this OTP, I'll copy class that will be responsible for this OTP generation. Then explain what we have there. Okay, so we'll go to this code. Okay, so this is a class that manages the user OTP. All right, basically the user OTP, and it makes use of random and string. Now we have a class attribute here, Redis, which gets hold of the Redis database that we have here. Can you see this Redis? It gets hold of this Redis database that we have here. Now the next thing is we have a method that handles token generation, and this is the method. It basically creates a random string of uppercase letters, lowercase letters, and digits, right? Then return this dot join for this in this. So basically, it iterates through this number, right? Don't forget that generate token takes a number, which is an integer, which is equal to, by default, is equal to 9, right? So it iterates over this number. We can set this to 90, or you can even set it to just any value you want. Let me set it to 9. It then iterates over that number, like from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then in each iteration, it creates this. All right, it creates either an uppercase or lowercase or a digit. Right, then it appends it to this empty string. So this is what this algorithm does, generate token. Now we have another method that handles OTP. Right, so this OTP takes a user ID, which is of type. Okay, let this be of type string. Then it takes an expiration. You know, this token shouldn't be there forever. Like sometimes you hear that maybe if you create an account somewhere, you could be told that you are expected to use this token within maybe 15 minutes or like 15 to 16 minutes or something. So that's just it. So the first thing we do is we call this generate token algorithm and it gives us a token. Now we check the Redis database at line 26. While this Redis has this OTP in it, right? You know, like we're using a while loop here in Python. Like while this condition is true, you should continue to generate a new token. So it will continue generating new token until we have a token that does not exist in that database. Now, if when we get that token that is not already available in the database, we can then set that token. All right, we can then store that token to the database, and we want it to set user ID as well. And then it also sets the expires to 900 seconds, meaning after 900 seconds, that data will be deleted. Then it returns the OTP back to the user. So that's how it works. Please, do you understand this class now? Do you have any question on this? Is there any question on this?
I have to go over the concepts again to fully grasp, but I think it's straightforward.
Okay. So let me count that. We have a generate token algorithm that takes the number of characters here as an argument, and in this case, it is 9. Right? What it does here is it generates a string of 9 characters that contains both uppercase, lowercase, and numbers. All right. Now we call this when you call the create OTP, you supply the user ID. That's the user you want to create this OTP for, and you supply the expiration. All right. When you want this OTP to expire, and in this case, you want this OTP to expire after 900 seconds. Okay. Now we then generate a token. Now, while this token exists in the database, like if we check this database and we see this token, generate and now then check again, generate and now check again. Now, if you have a token that is not available in the database, you then save that token to the database and then attach it to the user and to return this token to the user. So that's how we solve the problem of maybe having maybe having duplicate tokens. All right, let's say 45. Maybe if we already have a token that is 45 in the database and we come and create another token that is 45 in the database, it will have little issues later on because it will be difficult. It will be more difficult for us to identify what each user has. Like it will be difficult for us to know which user has which token. So that's it.
So before you go further, please, in the OTP.py, yeah. I was wondering what the for loop is actually doing. The for loop in the generate token. Okay, that generate token function. Yes, what the for loop is actually doing.
Okay. So you can see for underscore in range number. What this means is that it should start from 0 up to 8. All right. Then for each iteration of that for loop, it should choose, can you see this random dot choice? It means choose one of these, right? This or this or this, right? You should choose either an uppercase letter, a lowercase letter, or a digit, then append it to this empty string. So it does that at the first iteration, it does that at the second iteration, it does that at the third iteration, until we get to the number that we want. So that is how you have a random string of characters. So that's how you get a random string of characters. Okay. Now let us make use of that to create an OTP. We are going to instantiate this class. I'll call this class OTP manager. To instantiate this class, OTP manager is equal to OTP manager. OTP manager. Then we will then come to auth and import that manager and use it from within the code. From libraries, library.security.otp import OTP manager. OTP manager. Now from within our code, we can then create an OTP. OTP manager dot create OTP dot create OTP, and we should pass in the user ID. Then our user ID will be a string of. Please don't forget that our user ID expects a string, but here's what I mean. Can you see this user ID? It expects a string. Meanwhile, our ID is not a string, it is a UUID. So we are going to stringify it by just wrapping to that string. And we will get the ID of created user. This user we just created. That will be created user ID. And what else do we need to pass? We need to pass in the expire, okay? And that's optional. An optional value with the default value of 900 seconds. That's fine for us. So with this, we have an OTP. Now let us print that OTP. Let us print that OTP. All right. Now let us test this and see what happens. Okay, so can you see this?
Yes.
Yeah. So we have this random string KH270IDC. So this is that's what is generated at this particular function. It iterates, for each iteration, this random module selects either uppercase, lowercase, or digits. So you can see here some are uppercases, some are lowercases, and then some are digits. And it does that 9 times. That's why we have 9 characters. Yeah. So it keeps generating until we have a token that's not already available in the database. So that is that. Actually, that is that. Now you would then normally send this token. You then send this token as an email to the user. Then we will then create a new endpoint that will collect this token, check the Redis database for this token, and if we have the token, we then verify the user that has that token. Then if we do not have the token there, we can then safely reject the request as wrong. So before we proceed, I'd love to pause for questions. Any question?
Yes, so this our generated token for now is stored in the Redis database, the in-memory database.
Yes. It is stored in Redis. It is not stored in our main database. It's stored on Redis, the in-memory database.
All right.
Is any other question? No question, I believe. Okay. Now, the next thing we're going to do is to, okay, I'll create the, yeah, we should have enough time to create the verify this and the verify account. So now let me create a new endpoint that I'll do that. So our router, our code is verify account. Yeah, verify account should also return the user model. Now, I want this token to be attached to the requests. I want this token to be attached to the pattern. Now, this should be a string which is equal to path. It's required. We are going to import path from fast API. Okay, now let me pause this one now. Okay, please, do you have any question on this? Yes, any question on this?
Oh, sir.
Okay, so we are collecting the token. Let's say after we send this token to the front end and the user types this token on the app to verify the account, the request that is coming from the app, right, shouldn't have a body, right? We should just send a get request to this endpoint, verify account, then slash that token. So that is what we need. Let me change this to verify. Verify. So what we are going to do here is that we are going to look for a user that we are going to check the Redis database for a user with that particular token. Now let's go here and let us get another function that handles retrieval. So I want to create another method that will handle the retrieval of user OTP. Good. So this particular function returns the owner of an OTP. So when an OTP is supplied, it will then check if this OTP exists in that Redis database, and if it exists, it will return that OTP. That's why we have class.redis.get OTP. Then the data we are getting from the Redis is in bytes, so we decode it to UTF-8 and return it to the front end. And if it is not available, we return none at that point. So I'm going to check. I'm going to check if this token is valid. Does this token this user has provided is valid by calling that particular function we've created. So that will be OTP manager. OTP manager get OTP user. Now we need to pass in the OTP, which is token. Let me change this to OTP. 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 Now we will check if user code. Okay, this should be user ID, not user code. User ID. Now we'll check if user ID is known. Please don't forget that Please don't forget that this gets OTP user returns none if that particular OTP does not exist. Right, so we want to confirm that we want to check if this return value is none. So if user ID is none, I want to raise an HTTP exception. Yes, I just want to return an error to the front end that hey, this thing provided is not valid. Raise HTTP exception, which should have a detail. Okay, we should have a status code. We should have a status code that is I want it to be status dot before we use status, of course we need to import it. I want this to be status dot HTTP. I think we should use unauthorized. Then we provide a detail that your OTP is invalid. Now, if it is not, then we can get the user that has this particular ID, and you can get the user that has this particular ID. Then we then update the user and set the email verified to true. And so your get ID is equal to UUID then passing the ID. Then but updates. First, we need to update the email verified field. To true. It should no longer be false. It should be true. Then we should then return that user to front. Return this. Simply do it up. Yeah, that was long, please. Any question on this?
Oh, they get OTP user.
Yeah.
The decode
right.
UTF equals 8, yes. The code UTF/8.
Yeah.
Line 35. Line 35. Can you hear me?
Yes, I can hear you. I can hear you.
Yes, I was wondering what that does. The decode UTF.
Okay. So the data on Redis is stored as bytes. Right, it's stored as bytes. So you will have something like this. The blah 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 blah. All right. So we don't want this. We want normal pure UTF-8. So that's why we need to decode it to UTF-8 to remove that bytes we have already. So this is what I mean. We have something like token. When you pull it out like that, it's like this. Right? We have this B in front, okay, which signifies that it is a byte. So when you decode it to UTF-8, it takes that up, and you have something like this. So that's why we need to decode to UTF-8. We want to work with UTF-8, not bytes.
Okay, sir.
Can you hear me? I believe you can hear me, right?
Yes, I can hear you.
Okay. Sorry. Okay, so that is that. Now, if that token doesn't exist in DB, it returns none. Right. So within our code, we check whether the return value is none. If that return value is none, that means either the token is invalid or it is expired. We reject the request and raise an initiative exception. Now, if that token exists, right? If that token exists, line 36 will execute, and we will get that user and then update email verify to true. Then simply return user to the front end. So I think one more thing we need to check is it's a good idea to check if this is what I mean. If you look at our requests, we've been sending requests with the same name, right? Like test.com, meaning multiple users can sign up with the same email address, right? Which doesn't really make a lot of sense. I would advise you to maybe while you're going through the code, you should make changes on your own. Come to this register endpoint. Okay, come to register endpoint. Then before you create the user, before you execute line 18, maybe you can add a check on top. All right. What you should do is you should search the database for a user with this email. Like just check if you already have a user with the email that is supplied by the user, right? With the email and password that is supplied by the user. And if the user exists, you raise an initiative exception and just tell them that, hey, this email already exists, that the user should choose another. Okay, that's that for that. So
Okay.
let us test this.
Okay, so can we add a unique description to the field? Right, it happens automatically.
Yes, we can do that. But I actually don't want to have like I usually don't like the validation to be on the database because when that validation is not met, yeah, it will throw an error again. So it's better to run the validation on your endpoint. This is what I mean. You can actually say user is equal to await user.filter email is equal to data.email.exists. So Fast API has an exists method that you can call to check if a particular value exists in the DB. So let me call this exists instead. Now we will then create an if block which check if this user exists is true. Now, if this block is triggered, that means this email already exists in the DB. So I want to raise an exception. And I want the details to be status dot should be HTTP 401. Yeah, unauthorized, and I want the detail to be okay. Sorry, this should be status code, not. Now I want the detail to be this user already exists. All right, I hope you understand now what it means.
Yes, sir. Yes, sir.
Yeah, at line 18 to 22 basically checks that we don't already have this user. Okay. Okay, yeah, we should also check email. Okay, we should also check. Let me convert this to email exists. And let us check for username. We want the username to be unique as well. Username. We want to check the username. Now, if email or username exists, that's if either of this is true. If either of this returns true, we want to raise an HTTP exception. Now, if none returns true, we should go ahead and register the user. So let us test this and see what happens. Okay, we should get an exception here. Good, we have this user already exists. Let me use test one. We should get another exception that the username exists. I want something different. Okay, this user already exists, okay? We should also get an exception here. This user already exists, good. Now let us change the username and then check. Good, the account is now created and we've been given a token. Yeah. Now we're going to use this token to verify the account and then see what happens. Get auth verify account. Let's look at this email verified. Now it is false, but after sending this request, it should be true. Oops, internal server error. There is a problem. Let us check. Response value is not a valid dict. Return, oops. We returned user.get, of course, which is a coroutine object. We should actually await it before it works. So await this and see what happens. Please don't forget this user is you must always await it. Any, not just user, any tortoise ORM model should always be awaited. Good. So it's not valid. We have email verified is equal to true. Now let us see what happens if we send a fake token. So as you can see here, line 39 is activated and we have an error that our OTP is invalid or it is expired. Wow, that was a long one. Is there any question on this?
No, it's clear. Very clear.
Okay. Okay. So that is that's nice. That's nice. So I think that will be all for today. But I'll do you to go and like create an endpoint that would handle login. Right. We did this in a couple of classes ago. Like just create an endpoint that will take the user and the user email and the password. Then you get the user with that email. Then compare the hashed copy of that password with the plain text that the user supplied. And if they match, right, if it returns true, you generate a JWT token and give that to the user for further authentication. That's basically how authentication works on APIs.
You say we generate a JWT token.
Yes. Like when the user logs in with the username, with the email and the password, you first take this email, query the database if we have a record with that email. All right. Now, if a record with that email exists, you extract that record, then take the hashed password of that record. All right. Now, compare that hashed password with, like just verify the hashed password with the plain text password this user passed in during login. And if they match, all right, you generate a token and give back to the user for further authentication. So you can just try that out. It's not like an assignment here, but you can just try that out so that in the next class as you're doing it, it will be easier for you to understand.
Yes, sir. All right.
Okay. That's it for today. Thanks a lot for showing up. So I will push this code to, I think let me do that now before I forget. I'll push this code to GitHub so that you can clone and use it from there. Register. Now push this. All right, so it's live on Git. So that we got for today. Our next class will be tomorrow. We missed yesterday's class, so I rescheduled it to tomorrow by 11. Sorry, thank you.
All right, sir. Thank you very much. Thank you very much. Thank you very much, sir.
Very well, thank you. Thank you.